Hi friends, welcome to my YouTube channel on another video. In this video, we will cover demo on HTTP2. Before starting the demo, I would like to mention that I have created a separate channel, Shades on Canvas, for all my sketching content. So all my future sketching video will be getting posted on that channel only. I will post the link to that channel in description as well as in the comments. Please visit that channel if you love some sketching content. So let's start this video. Let's start with the multiplexing. Let me start the server on that. cd multiplexing and server. Now if I go to this URL and if I open my network tab, let me use this and make 3 parallel requests, right? So here I'm making 3 parallel requests. So I'm just adding a delay in the query params on all these requests. So if I expand it a little bit, let me expand it. So as you can see, I have added a delay on this. So delay on all the 3 requests are exact same. And as you can see, the connection ID on all these 3 requests is exactly same. So if you will look into my demo on HTTP1, right? So there you will see when you will make 3 parallel requests in HTTP1, the connection ID is different for each of them. Because in HTTP1, when browser makes parallel request to the server, it creates a new connection for every request. But here in HTTP2, as it uses the same connection for all the requests being made from client to server and vice versa, the connection ID here is same for all of them. And all the requests are going in parallel and ending at the same time, right? They all took same time. Same time to complete, right? Because the delay on every of them is same. That is why it is looking there. It is all these waterfall models are in parallel to each other. So if we let's say add some more delay on one of them, let me go to my code on multiplexing. So here on the server, I'm just sending a file in the response on the API. I'm just sending some dummy response in the API. So as you can see here, I'm using the stream. So instead of if you have worked on the HTTP1, you send it in the response, right? Like you do something like this in Node, rest.send, response.send. There is a request response object uh, being sent in the API function, right? And you use those to send the data or to read the request body, right? So here, instead of using those things, I'm sending the response in a stream, because HTTP2 works in a stream, right? Whenever a request is being made from client to server or vice versa, data transfer from server to client, a stream is opened, and on that stream the frames are traveled, right? And frames can be interleaved. Like they cannot be in sequence. They can be out of order, and on both the client and the server, the frames are assembled, and the full request or response is read by the receiver. So here you can clearly see, instead of using the response, I'm using a stream method given by HTTP2, and I'm sending data in a stream instead of sending the full response. If you will look into my index.html, here I'm just adding a delay. So let me change these delay for different delay for different requests. Let me change it to something like this. And now if I start my server again, let me quit it and start the server again. Now if I refresh my page here, how to close it? Yeah. Now if I start all these 3 requests, as you can see, they all started at the same time. So as you can see, all these 3 blue lines, let me expand it a little bit. These 3 blue lines started at the same time, right? But they all took different amount of time to get completed. So let's see their completion time. So here it is 1 second, 2 second, and 3 second, because the delay is accordingly, right? According to the delay, they took different time to get completed, but they all started at the same time. So this is how multiplexing works. Like the request doesn't wait for another request to get completed. So here the first request delay is 3 seconds, right? But instead, as you can see, the third request got completed before the first request. But in HTTP1, if you remember, if the connection ID is same, the second request has to wait for first request to get finished before even starting, right? But here your third request, which is with minimal delay, is getting finished faster than the first request. This is because here the requests are not waiting for any other request to get completed. They are all independent, and they all use independent frames and streams, and that is why there is no blockage. This is how HTTP2 has resolved the head of line blocking of HTTP1. Even with the same connection, every request is independent. They don't have to wait for others to get completed. So this is all in multiplexing demo. Let's go to the flow control. Let me quit it and move back to flow control. So here I'll just start my server and refresh my page here. So now this is the flow control demo. I start the download here. So you are seeing all this, right? Received bytes again and again. So in this, it's difficult to demo. I'll show you it in the terminal. But here, as you can see, only one request is being made, right? In the network tab, only one request was being made for this data request, right? And in the response, as you can see, there is nothing like this HTML or something. So what is happening here? Here I'm just sending some random bytes, some random dummy data in the response in chunks. I'm not sending all the data in one go. I'm sending it in chunks. And on my client side, I'm just calculating how much size I have received. So the total limit is 50 MB. So once it has received 50 MB, it will stop then receiving, and otherwise it will just show what chunk it has received. So if you will look into my code of flow control, let's go to the client first. Here on the browser side, I'm reading it from the server, and based on the data I'm receiving, the size I'm receiving, I'm just um, I'm just logging the total size there. I'm just adding the text content here in the HTML that this much byte I have received. Also on the server, if you will see, I'm just sending the chunks. I'm creating a chunk of 32 KB at one time, and I'm sending that chunk on the stream, and I'm just sending the chunk until unless my total size is 50 MB, which is the limit here. So let's observe it in the client side. On the terminal, on the client, let's make a call using terminal, and here I have added a delay. I have just paused the request for let's say 100 milliseconds. I will just pause the another reading of data for 100 milliseconds, and let's do it on the client side. Let's go to flow control here in the terminal, and I will just start my client here. So as you can see here, the data is being received in chunks. So initially the size is 0 because you are getting 32 KB in one go, and until unless it is the total size is 1 MB, you will see 0 MB here. So it's saying that receive these many bytes, receive these many bytes. I think we are sending 16 bytes, not 32 bytes, but we are receiving it in chunks. And once it gets 50 MB, it will stop receiving. So it will take some time. Let me quit it and reduce the delay to 1 millisecond. So let's do that. Let's do it for 10 milliseconds. And let me start my client again. So yeah, as you can see, now it's 1 MB, 2 MB. It will still take some time, right, to get 50 MB. Let's reduce it even further to 1 millisecond. And now let's try it. Yeah, now as you can see, it's much faster. And now once the 50 MB data is received by the client, it will stop. Yeah. After 50 MB, it's stopped, right? So in the stream, you can send the data in the chunks instead of sending it in a one go. The client will receive data frames for every chunk. For every chunk, it will create a new frame and it will send it to the client. And once all the chunks are received by the client, it will just stop the connection. So that is about flow control. Let's move to header compression. Let me go to my header compression video, the compression directory, and start the server again. Now here if I refresh my page, so this is my initial request that will send me this small HTML. I'll just clean it up. Now if I send some repeated requests, so here what am I doing? I'm just making 10 different requests, exact same request I'm making again and again. So if you will see, all the things are same here. So let's compare first and second request. So here the response being received by the client is same, and if you will see the request and response headers or all the headers, you can see everything is same URL, method, and remote address and everything. So here in the response headers as well, everything is same: session ID, user ID, client version, and as well as all the request headers are also same. But there is one difference in these requests. The first request that is being sent by the client, it is taking the size of 0.2 KB, but all the other requests that are being sent, they are just of smaller size, right? Why this is the case? This is the case because of header compression. So if you will remember from my theory lecture, in HTTP2 there is header compression, right? And it manages two tables, static table and dynamic table for header compression. So initially when the first request is being made, those headers are not present in that table. So the full data is going in the request, and these data is going in the request as a with the key value, like a key value thing. So this actually goes in the request. These value actually goes in the request because they're exactly same, right? Now after this, when the second request is being made, the data is present in the tables, right, in the dynamic table. Then only the the indexed entries to those table will be sent instead of the actual header. So here you cannot see any difference because browser does not do that. Like that happens internally. Here you will still see the actual headers being sent for your readability and for your debugging purpose. Here you will not see any difference. The only difference you can see here is like the size difference. Depending on the size has reduced. This is because of header compression. But internally, these headers are being compressed and only the indexed entries are being sent to the server or vice versa. This is how header compression works. So here if you will see my code on the header compression. So here in the code, let me go to the index.html. Here I am just making, in a loop I am making time request to the exact same endpoint, right? So still this size on the browser is different. So that is how header compression works. Let's move to another demo on uh, prioritization. So let's start this one. CD prioritization, and let me start the server here. So let's go to the code here first. In this actually I'm just manually prioritizing my streams based on the resources, so video, css and ads. So let me reduce the weight for ads like really low, and based on the weights that I've assigned to those streams, I'm just manually picking up a stream, and I'm picking up the stream which has higher weight more often, and the stream that has lower weight less often, and sending the data on it. So let's see how it works first. So let me go to this URL and refresh, close this. So as you can see, okay, I think I have not refreshed after my code change. So let me start my server again and let's refresh it again. So as you can see, here video stream is going like really faster. See, after that CSS stream is getting filled up and ads is like really low because it's not being picked up really often. Because here if you will see the weight on the ad is like really low as compared to CSS and video, right? So that is why this ads is like picking up very rarely. So that is why it's not filling up. So if you will wait for some time, let's say a minute or two, we will see some progress here, but it's very rarely getting picked up, right? So that is why it's not getting filled up. So let me change the weights on ads. So instead of using it 1, let's do it 50. And yeah, you can see it started coming, right? But this is with weight 1 only. Let me start my server again with weight 50 on ads and now see the result. So as you can see, now this is also getting filled up like really faster than before, right? But still slower than CSS. So because the weights are comparatively large here, this is also getting filled up, but yeah, still slower than CSS and video. So this is just a manual demo on the prioritization, because here after assigning the weights, I'm controlling manually how the data will be sent on the streams based on their weights using this set interval function. So here I'm just checking the weights on each stream, and depending on the weights with the random function, with higher probability on the stream with higher weight, I'm picking up a stream and sending the data to it. But if you want to check the uh, real prioritization that happens on the stream and connection level, where you set up weights or size limits on connection, you can just check this one. So here also, and here let me show you first on this demo. Let me go to real real S2 prioritization, and here I'm using S2 to run my server. So let me start my server here. um, let's clean it up first and start my server here. Now let's clean it up and run my client. So in my, I'm using ng HTTP client here. So if I run my client here with two requests to the server. So if you will see my code here, I have added two files here, big one and big two. These are random files with big size and random data in it, and I'm just fetching these two files in my client with different weights. But let me start that. So it happened really fast. So if you will see the logs here, I'm running it in a verbose mode, so you can see all the logs here. So if you will go through these logs, so it first opened a stream for some setting frame to make some settings on the server with the stream ID 0. Then for these two requests, request 1 and request 2, headers are being sent. So as the request started, two streams were opened with ID 1 and ID 3, and these two headers were sent. Then the settings were received from the server after first it sends it, right, sends the settings, sends the headers, and sends the request and everything. After that it started receiving the response from server. So settings were received from the server, then headers were received from the server for both the request in the same stream. As you can see, whatever stream ID is present here for setting, in the receiver frame as well, the same stream ID is present. Similarly, for these two requests for big 1 and big 2, big 1 bin and big 2 bin, you can see whatever stream IDs are present here, 1 and 3, same stream IDs will be present in the receive header frame as well. Stream 1 and stream 3 for big 1 and big 2. And for the data frame as well, until unless the request is completed, same stream IDs will be there. So data will be traveling in the same stream, stream 1 and stream 3. Stream 0 is for settings frame. And also whatever window update frame is being sent for those requests. So as you have seen in my theory video, there are different types of frames, right? A setting frame, data frame, window update frame. Window update frame is usually a way to tell the server from client that send me some more data. So that is what happening here. First the header is received, the data is getting received by the client. Then client will send some window update frame on the same streams, stream 0 and stream 1, saying the server that send me some more data. After server receives that frame, it updates the window size and sends some more data. So this is what happening here again and again. Client sends some window update frame, then the data is received on both the request streams. Then again the window update is happening, again the data is getting received. So this is all is happening here. It will continue to happen until unless the requests are completed, until all the data is being sent by the server. So in the end, as you can see, after the data is completed, in the end, you can see there is a go away frame going on. So if you remember from my theory lecture, this go away frame is for terminating the connection, right? Because every request and everything is completed here, right? So now it's terminating the connection. So it's saying that lost stream, is it losing the streams and everything, closing everything. So this is what happening in this. So here as you can see, this data is coming in round robin, right? There is no prioritization yet, right? There is no priority on a particular stream. This is because the S2 that I'm using here is of older version, and here it doesn't support prioritization. Like it doesn't support external flags to set some priority. So whatever weights I'm sending here in my NGT HTTP request, these are being ignored by my S2O server. So I have done some debugging here, but I found out that it is possible in version S2O 3 point something, 3 or more than 3 point something. Then in that you can set up the prioritization flags here in the config, and then whatever weights you will provide here, they will be taken into consideration by the S2O server. But setting up that will be taking some time. So I have not done that. Maybe you can try it on your own. But all I wanted to show you here is different types of frames. So instead of like HTTP one, here everything works on frames, window update frame and data frame and all. So if I, let's say, remove one of the requests, right? Let's say if I made only one request, you can see there will be two streams open only, one for settings and one for request. So first the settings stream is there for 0, and one stream is there for my request and response. And all the data frames they are using all the data frames belong to my request only, right? So they all are using stream 1. All of them are using stream 1. Earlier there were two streams, right? 1 and 3 for different requests, right? So data frames were using 1 or 3 depending on the data belonging to a request or response, right? But here all the data frames belong to a same request, right? So all of them will be of stream 1. And once everything is done, go away frame is going and the connection is being closed. Okay, that is all here. Let me move to my last demo, server push. So server push demo is not possible because this has been dropped from everywhere, from browser, from Node. So I just wanted to show you that it has been dropped. Let me close this, and in the server push demo, in the server, I'm using server push function provided by HTTP to send me some data. So when serving the index HTML, I'm trying to push CSS as well as my JavaScript file as well in advance. So once I started this server, node server.js, and once I hit the browser, you can see here this is getting terminated, throwing an error that this has been disabled now. HTTP2 push disabled, right? So Node has dropped the support for server push. You cannot do it anymore here. Maybe you can try some other language to create a demo of your own, but Node has dropped the support here as well. I'm not sure about other languages, if there is some older version in other languages that will still support it, but Node has dropped support completely for it, and this is not possible with older versions as well. I tried with 10, 12, and 8, Node 8 as well, but it is working nowhere. With the browsers as well, once I started the server, with the browser as well, if you make the request, okay, not this one actually, let me start this one. I tried to create another demo with S2 as well, but there as well the server push is not happening. So let me start my S2 server here. Now if I hit the browser, you can see there are okay, let me refresh it again. You can see there are three requests being made: localhost, style.css, and app.js. So here three requests are going, right, but there is no mention of push anywhere. So earlier in the older browser there was a label being mentioned here if the push was happening, but there is nothing like that here anymore. Similarly, if I use my client, right, if I go to my readme, if I use my ngHttp client, so let's try this. There, as you can see, I'm only getting HTML. I'm not getting CSS and JavaScript, and there is no server push frame. So there was a frame for that represents the pushing is happening, but there is nothing anymore there. So this is not working anymore, and it has been dropped from everywhere. Okay, this is for this demo video. Thank you for watching. I hope you liked it, and we will see you in my next video on HTTP 3. Till that time, thank you so much.